So before we start learning about features of an exponential function, we're still going to learn a bit more about exponents. And now we're going to add in rational exponents. And rational is just a fancy way of saying there's division, so we're going to have a fraction in our exponent. All right, that's exactly what this says. All right, so our first definition we need is that if we have a fraction of 1 over n in our exponent, that is the same as the nth root of x. So these mean the exact same thing. You can always go back and forward. All right, and there's actually a lot of cases where you want to go back and forward. Sometimes having the exponent written is better. Sometimes having the root is better. All right, but just a simple example is x to the 1/2. All right, well, 1/2 is going to tell me that's the second root, which is the same as the square root, which is the one we don't write. So the x to the 1/2 is the same as the square root of x. Right, there's a really special case for exponents where we can kind of write it as something else that we already know. All right, so evaluate each of the following. So all these don't really make sense as an exponent. All right, so pretty much all of these we're going to rewrite using our root. 4 to the 1/2 is the same as the square root of 4. Just two ways of writing the same thing. But we can figure out the square root of 4, that's 2, because 2 times 2 is 4. All right, 9 to the 1/2 is the same as the square root of 9. And the square root of 9, what times itself equals 9? That's 3. 16 to the 1/4. All right, now we have a 4 on the bottom, so this is where we do write the 4 for the root. All right, so this is the 4th root of 16. All right, so remember, this is what you're multiplying by itself 4 times, all right, because of that 4 there. All right, what do I multiply by itself 4 times to get 16? Always start with the smallest number 2. 2, 4, 8, 16. All right, so it is 2. And then the last one, 125 to the 1/3. All right, our root is the 3rd root of 125. All right, something we multiply by itself 3 times to get 125. And then you can do a little bit of guess and check. If you try 4, you get 64. All right, but then if you try 5, you'll get 125. So 5 times 5 times 5 is 125. All right, so the 3rd root is 5. All right, so you can see we had these fractional exponents. Just rewrite it as a root and think about that multiplication to get your answer. All right, so here's one for you to try on your own. What is 36 raised to the 1/2? All right, hopefully you knew that 36 to the 1/2 is just the square root of 36. So we're looking for a number that you multiply by itself to get 36, and that is 6. All right, so now we're just going to go one step farther. Not every single fraction can be written as 1 over some number. A lot of fractions like 3/2 or 5 over 7, all right, they all have an extra number on the top that's not 1. All right, so how do we deal with that? Well, if the top is not 1, we're just going to break it down into 2 steps. All right, so in this example, we have m over n, all right, just some fraction. But we're going to break it up. So the m part, the top part, we're going to separate out from the fraction part, the 1 over n part. And this is what we just learned. The 1 over n part is the same thing as the nth root. The m part, the whole number, is the same as always when you're just multiplying a number by itself. So these are just 2-step problems where we take a root and then raise it to a power. All right, so let's see it in action. All right, so 9 to the 3/2. The first thing I'm going to do is separate it into 2 pieces. So the fraction part is the fact that there's a 2 on the bottom. So I'm going to put the 1/2 without the 3 first. And then this 3 on the top means I'm going to put the 3 whole number by itself out there. And why are these 2 things equal? Because we have this exponent rule that if you raise a number to 2 exponents like this, you multiply the exponents, and 3 times 1/2 gets me back to 3/2. All right, so I separated it out into 2 pieces, but now in here is what we just learned earlier in the video. That's the square root of 9. The square root of 9 we already know is 3. All right, so I simplified inside that parenthesis first, and then 3 cubed is 3 times 3 times 3, which is 27. All right, so my final answer is 27. All right, 16 to the 5/4, and we're going to separate it into 2 pieces. So the bottom is the 4, so we're going to have 16 to the 1/4 as the first part, and the whole number top is 5. The inside of the parentheses we've actually already seen is the fourth root of 16. Something times itself 4 times to get 16 ends up being 2. And then 2 to the 5th is 2, 4, 8, 16, 32. All right, so we're multiplying by 2 5 times, and we get 32. All right, in this example, all right, same thing, but now we added a negative exponent. All right, we learned about negative exponents in our previous learning objective. All right, the setup's still going to be the same. The first thing we do is separate out the fraction part. All right, so the bottom here is a 2, so that's going to separate out. And then the number on the top is a negative 1, so that's what's going to go up here. And again, order of operations says we should simplify inside this fraction first. So 4 to the 1/2 is the same as the square root of 4. The square root of 4 is 2. In our last video, we learned that 2 to the negative 1, it wants to go to the other side of the division bar. That's what a negative exponent means. No division bar, so we create a division bar by dividing by 1. This becomes 1 over 2 to the positive 1. And that's just 1/2. This example, not much is going to be different. All right, we separate the fraction part first, so 27 to the 1/3, and the number on the top of the fraction second, negative 4. All right, so just notice that this first part always has a 1 over fraction in there, because that's where we can just rewrite it as a root. The cube root of 27, something multiplies by itself 3 times to get 27, that is 3. And then same thing we did in the last problem. Now we have to do 3 to the negative 4. All right, but that negative exponent is the most important part so far, is that that's going to move this to the other side of the division bar to become 3 to the positive 4. And then 3 to the positive 4 is 3, 9, 27, 81. So 1 over 81 is our final answer. All right, so just putting together the two things we've learned in the previous learning objectives, negative exponents, and now these fractional exponents, which is another way of doing a root. All right, so here's one for you to try and figure out what is 8 raised to the 2/3. All right, here's what you get. Again, the first most important thing is separating it into 2 pieces. So 3 is on the bottom, which tells me this is going to be 8 to the 1/3. This 2 is on the top, which means that squared is going to be there. All right, this is our definition of what 8 to the 1/3 means. It's the same as the cube root. The cube root of 8 is 2. All right, 2 times 2 times 2 is 8. And then the last thing we have to do 2 squared, which is just 2 copies of 2, and I get 4. All right, so for this learning objective, you're going to have to do a skill check. All right, the skill check will have 2 problems where you need to switch between exponents and radicals. Just rewrite it. You don't actually have to work it out yourself. So if you see like x to the 1/3, you just know you have to rewrite that as the cube root of x. If you see the 5th root of x, you just know you have to write that as x to the 1/5. All right, so that's the first one, just rewriting things without actually evaluating stuff. And then the second one is just like the examples we did in this video, where you have to figure out what the answer is for these fractional exponents.